Hello guys, this is Prime Concept. In this video, we want to see how we can find or calculate the area of a triangle and then area for polygons, right? Using the concept of coordinate geometry. So we want to see this, but we won't be deriving this because it's very simple to derive but might be very time consuming. So I will just go straight to inserting the formula. Now say we want to find, we have a triangle like this. I have a triangle like this of any shape. So say we want to find the triangle. Remember we have different types of triangles. So any one of these triangles, scaling triangle, equilateral, right angle, we can always use this formula to do that. So we have this is B and this is C. So these points have, this is coordinate x1, y1, this x2, y2, and then this is x3, y3. So we want to find the area of this triangle. So what we're simply going to do, because area is always a positive quantity, so we don't want to get negative. So we're simply going to say the area of the triangle is half into the absolute value. Absolute value means if you get a negative answer, it makes it positive. So the area of the shape should always be a positive quantity. So the area is going to be half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is a formula we can use to find area of a triangle. So observe how these things are. This is x1, this is x2, and this is x3. So you notice if you have x and the subscript 1, then you shouldn't have 1 again in your subscript for y. Similarly, if your subscript for x is 2, you shouldn't have y again. So, and how do you remember this? Me personally, I use knowing that I'm going from down to up to down. Because since you say y2 minus y3, it means y2 is smaller. So I'm going from small to big to small. What do I mean? 2 to 3, this is small. 2 minus 3 is going to be small. 3 minus 1 is going to be big. Then 1 minus 3 is going to be small. So I should remember that it should be small, big, small. So if you use that, you can remember or memorize this formula, right? Now for a better understanding of this formula, if you can still not memorize it, then we have another simple version for you, which is using the concept of matrices. So if you want to solve area and you're finding this difficult to remember, you can simply convert that into a matrix. So the area of a triangle in matrix form, which is simply just translating this, is going to still be the absolute value. Remember, we have 1/2 outside, then the absolute value of the determinant of our matrix. This is absolute value. This one will stand for determinant of our matrix: x1, y1, x2, y2, x3, y3. Now to make this a 3 by 3 matrix so that we can find the determinant, it's going to be, we'll just put 1, 1, 1, because you've learned that when you multiply something by 1, it does not really change it. So we're adding 1, 1, 1. So this is a formula you can also use that will give you the same result as this one. So I believe this one is easier to remember, right? Yeah, so we're going to use this concept to solve a simple problem on area of a triangle. Now, let's consider this problem. Let's consider this problem very quickly. Now we have this question on the board. The question says, find the area of triangle with vertices. Vertices simply means the ends of a triangle. Vertices A, B, and C, right? So we're going to use the matrix form to quickly solve this. So arranging, our area is going to be half outside. Don't forget this half into the absolute value, which we know now. So let me just go straight to determinant. Now let's call this x1 and y1. So I would have 1 and 4. Let's call this x2, minus 2 and what? 8. This is going to be minus 7 and minus 7. Then I'll complete this with what? 1, 1, 1. Right? So this is how we can find the area of a triangle. Now, what we want to do here to get our answer is to get the determinant of this matrix and multiply it by half. Then that is the area of your triangle. So I'm going to use the Soros method in finding the area of this triangle, which is very simple. So learn with me in this video how to find determinant using the Soros method. So I'm going to leave these two. Just ignore the two. Let's solve for determinant. So my matrix is 1, minus 2, minus 7, and then 4, 8, and minus 7, and then 1, 1, 1. This is my original matrix. Now, in order to find the determinant of this matrix using Soros method, what I'm going to do quickly, I'm going to reproduce this in front, then reproduce this in front. So let's start with this. So I'm going to have 1 minus 2 and minus 7. Then I'll reproduce this again, just the first two columns. So I would have 4, 8, and minus 7, right? Now, if I do this, I'm going to connect the diagonal that is up to 3. So I would have this. So this is one diagonal. Then I have that's up to 3. I have this is another one. I have this. I have this is another one, right? So I'm going to multiply in that direction. So my determinant is going to be 1 times 8 times 1 is 8. This is what? This is minus 28. All right, let's quickly, let me not make a mistake. My head is full. So minus 28, then this is plus 14, right? Then if you are done multiplying out in this direction, you close it with your bracket, then put minus. Then you're going to multiply out in the other direction also, which is this, 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 and then this, right? Yeah, so this is what you have. So you're going to multiply out in this direction also. This times this, minus 7 times 8 times 1 would give us 7 times 8 would give us 50, minus 56. Then this is minus 7. Then this is minus 8, right? So that if we add up, 8 minus 28 is minus 20, plus 14 is minus 6. So I have minus 6, right? Then I have minus, which is this. Then this, I have 56. So 7 and 8. So which is minus 71, right? So that if you solve this, minus becomes plus. So you have 71 minus 4. Then your determinant becomes 67. Remember, assuming your determinant was negative, you still take the absolute value. So it becomes positive. Therefore, our area is going to be half times determinant. Half times what? Determinant. So which is going to be half times 67. So and our answer is 67 divided by 2. So our answer is 33.5 square units. So this is how you can find area of a triangle using your determinant method. Now somebody may say, how do we find area of a polygon? Very simple. You don't have to learn a different formula for finding area of a polygon. Let me illustrate what we mean so that you can easily know how to find area of a polygon. Now, say you have any polygon. Let's use a quadrilateral, right? Say we have a quadrilateral like this. Quadrilateral is a polygon with 4 sides. So you can use any one, pentagon with 5 sides and so on. Now, say we have this. I want to find the area of this quadrilateral, right? So what you simply do is to divide this quadrilateral forming triangles from your quadrilateral. So if you can do that, it means I can draw a line like this. Then if you look at this, you will clearly see that we have two triangles here. So this is A, this is B, this is C, and this is D. Then we have two triangles. So you're going to find area of triangle ADC, and then find area of triangle ABC. So when you find area of triangle ADC, find area of triangle ABC. What do you do to find the area of this quadrilateral? It's now going to be the summation triangle ADC plus triangle ABC. So the sum of the area of this triangle will give you the area of the quadrilateral. So when you're given any regular polygon, you want to find the area, what you simply do is to split that polygon into the number of triangles you can get, then find the area of each triangle, then add up everything. That becomes the area for a polygon. So in my next video, I'm going to solve a problem on area of a polygon. I believe this concept is clear to you. If you enjoyed this video and you are yet to subscribe, please hit the subscribe button so you will get more valuable content from me. Like my videos, comment, and share with 10 of your friends. Tell them this is Prime Concepts. Thank you.